Start recording now. Share my screen. Let's get this show on the road. Here we go, shall we? Here we go, Jeopardy round. Here we go. Welcome everyone to today's Jeopardy round. So let me introduce you all to today's opponents. The first one we have here is iodide. You all know that element on the periodic table. The second person we have here is we have tetra. Tetra right there. And then, which represents our molecular geometry, and the Brookdale bear. We had to have him for a Brookdale project. For chemistry. We had to do that. The Brookdale bear. I had to put him in there. I felt like it. Really felt like I had to with this project. So let's get this show on the road. I will be doing voiceovers for them, being like they're stuffed animals, but I figure that's what we do to make this seem a little more realistic. See what we can do here today. Jeopardy board. Today's categories, we have solubility, we have vocabulary, dispersion, boiling points, phase diagrams, and other. So, the Brookdale bear, I'm going to have you pick a card from here. Whoever gets the highest number picks first. Go ahead. Show it to the camera. A 1. Brookdale bear, you got a 1. Not starting off good for you. Tetra. Your thing fell, I'm sorry about that, but let's pick a number here. 2. Looking a little bit better for you. Iodide. You need at least a 3 or higher to go first. 9. Iodide. You are up first to pick today's categories. So iodide. Make your pick. I'm going with boiling points for 300. Boiling for 3. Okay? As you add more London dispersion forces, what happens to the boiling point? How do London dispersion forces increase? Brookdale bear. When you add London dispersion forces, the boiling point goes up. And when the boiling point goes up, yeah, the boiling point goes up. And how do they increase them? That's what you're asking. They increase based on its atomic number. The more protons in the nucleus, the more your atomic number is. And the higher the boiling point. You are right, Brookdale bear. 300 on your end. So, as electrons increase, it's the same thing with protons if it's non-ion. London dispersion forces increase, and so is the boiling point as a result of it. So, London dispersion forces go up, boiling point goes up. Back to the board. Brookdale bear, You got the last question. You have the lead. Pick our next category for us. Boiling points for 500. Boiling for 5. Little risky here, I see. There we double, okay. Boiling points for 500. Let's see what the question is. Rank the following compounds. Wait, not compounds. Rank the following elements. I gotta correct that when we fix the PowerPoint. Rank the following elements in terms of increasing boiling point, starting with the lowest boiling point first. Ga, Ne, and Br2. Tetra. I'm going to go with Ne, Ga, and Br2. Right. So, Ga, forget that element. So Ga is gallium. Gallium has an atomic number of 31. Neon has an atomic number of 10. And bromine has an atomic number of 35. So, as atomic number increases, so is the boiling point. So, the first one is neon, because that has an atomic number of 10. Then we have gallium with an atomic number of 31. Then we have bromine with an atomic number of 35. Well done, Tetra. 300 for you. Well done, Tetra. 500 for you. 500. Tetra, you have control of the board. Which one would you like? Phase diagram for 2. Phase diagram for 2. Okay. These are the 3 factors that affect the physical state of a substance. These are the 3 factors that affect the physical state of a substance. Iodide. What are intermolecular forces, temperature, and pressure? You are right. Intermolecular forces, temperature, and pressure. Right. So iodide, you have a lead of 200. All right. So far, so good. This is looking good. Anybody's game here today? Checking my battery. So far, so good. 200. Iodide, you did good. You got control of the board. Phase diagrams for 5. Phase diagrams for 500. Not boiling point for 5. I hit the wrong question there. Ignore. The answer comes up as phase diagrams for 5. Oh, shoot. Got the wrong link there. Phase diagrams for 5. Describe the phase changes that occur when the temperature of water is increased from negative 100 degrees Celsius to 400 degrees Celsius at a pressure of 15 atm. Iodide. 15 atm. You go from a solid to a liquid at 100 degrees Celsius. Then we go again. We go from a solid to a liquid at 0. Then from 0 to 100, we go again. No, that is not at 15 atm. That is at 1 atm. So no, iodide, that is negative 500. So now you have the charge of an electron. Negative 300. Don't worry, iodine. You only have 7 electrons in your outer shell. Oh, shoot. I just left my knee on that one. All right. Nope. So iodine, you're down to negative 300. And Brookdale there. You want to get going? Yeah. At 15 ATM. It's a solid up to 0 degrees Celsius. The liquid until that point, then it becomes a gas at 250 degrees Celsius. Right. Good answer. Bold move. Strong. 500 for the Brookdale Bear. Okay, here we go. Move through. Brookdale Bear, you have control of the board. Other for 400. Other for 4. Daily double. You could wager up to 800. You could wager 1,000 because you're under 800. So how much do you like to wager? 1,000. $1,000. Okay, here's the big wager. What word represents the curvature of a liquid as a result of adhesive forces and cohesive forces? What is it called when adhesive forces is greater than cohesive forces and vice versa? So all for you, Brookdale Bear. That word is the meniscus. What is a meniscus? And when cohesive forces are greater, it's convex. And when adhesive forces are greater, it's concave. Good, that's 1,000 for the Brookdale Bear. You were way ahead of the game. Good going. So as we said, as Brookdale Bear said, that is a meniscus. When adhesive forces are greater, adhesive forces are the forces when different particles interact, and cohesive particles are when the same kinds of particles interact. Good. Other for 4, we just did. Gonna check this link real quick. Other for 4, we just did that, okay? Brookdale Bear, what would you like? Other for 5. Other for 5, go big or go home here, right? Here we go, other for 5. What happens to the density of the water when it freezes? Explain why density is important to sea life. Iodine. This is your chance to get out of the negative. What happens to the density? Ooh. So the density decreases. Right. The density decreases and the lake freeze, the waters freeze, going from the top to the bottom, so they can survive on the bottom. So anything on the top dies out because the water freezes. Good, good answer. Iodine, I like that answer. You lost all your electrons, and you're back up to 200. Now you have control of the board. Back to the board, you got control. Dispersion for 1. Dispersion 100. Okay. Is there less of a chance or a greater chance for dispersion when the molecules are spread? Tetra. What is a greater chance? Greater chance. You are right. Tetra 100. Dispersion for 1. Good move. Tetra, what is your next category? Dispersion 2. Dispersion 2. Okay. This is the strongest dipole-dipole interaction. Strongest dipole-dipole interaction. Where is it? Brookdale there. What is a hydrogen bond? Hydrogen bond. Yes, that is the right answer. Hydrogen bond. So you're up. Brookdale there, you were way ahead of the game here. You were up to 2,000. Brookdale, we know what you use. You picked the next category. Dispersion for 5. Dispersion 5, risky. Explain what dispersion forces and temporary dipoles are. Tough one. Explain what dispersion forces and temporary dipoles are. Iodide. Got no clue. Then why did you say the answer? Of course, you're back to negative 500 again. You're back to in the negatives. You electron lover. Brookdale bear. Dispersion forces are the intermolecular forces caused by the dipoles being there. Those temporary dipoles being there. And the temporary dipoles are the separation of charge. Like the charge is being separated. And that produces atoms, molecules. But by a not so even distribution of electrons. Good, Brookdale Bear. You are way up. You're at 2,500 right now. You are running away with it. See where we're going next. Okay. Next clue, Brookdale Bear. You have the control of the board. Dispersion for 4. Dispersion for 4. Just did dispersion 5. Dispersion 4. What happens to solubility when dispersion goes up? The energy of hydrogen bonding goes down. Iodide. What is it decreases? Decreases. Good. Yes, iodide. Good move. 400. You're back on the board. So the dispersion is increasing. The hydrogen bonding is decreasing. So as a result, the solubility is decreasing. Because hydrogen bonding is the strongest kind of bonding, and that causes solubility. So that brings it down. Okay, let's move forward. I just got my pen. Get that. Dispersion. So iodide, you have control of the board. Dispersion for 3. Dispersion 3. Okay. As size increases, what happens to dispersion? Tetra. What is it? Goes up. Goes up. Increases. Good. The size goes up, so is dispersion. So, Tetra, you are up to 900. The Brookdale Bear, you are at 25. You are at iodide, you are at 100. At least everybody's in the positives right now. You got all positive charges, protons, got them. Good going. So dispersion is wiped out. What would you like, Tetra? You have control of the board. Phase diagram for 100. Phase diagram for 1. This is a graph of the fact that stabilities of a substance's physical state depend on pressure and temperature. Brookdale, what is a phase diagram? Yes, phase diagram is exactly the kind that it is. Brookdale, there you got control of the board. Phase diagram for 4. Phase diagram 400. Okay. Explain the terms triple point and critical point. explain the terms triple point and critical point. Let's see. Iodide, what you got? Triple point is where, like, all the phases exist at the same time. And the critical point is where it has, and liquids and gases have the same density. Like the temperature or pressure that happens up. Good, yes. Iodide, you got that one. Good going. You're back in the positives again. You're up to 500 hour subtotal now. Brookdale, you're up to 2,500. Tetra, you're up to 900. And we are back to the board. Iodine, you have control. Phase diagrams for 3. Phase diagrams for 3. Okay. Here we go. Explain the terms supercritical region and supercritical fluid. Tetra. Explain them. Supercritical region is where it has both gas and liquid properties. Supercritical fluid is substance above the critical temperature and pressure. Good. Yes, Tetra, good move. You got 300 on phase diagrams. Good going, so you're up to 1,200. Phase diagrams we're all done with. We're all done with dispersion. Got a bunch of solubility, vocabulary. Tetra, you got control of the board. Solubility for 5. Solubility 500. Calculate the concentration of carbon dioxide in Coca-Cola that was bottled under a partial pressure of 3.2 atm CO2 at 40 degrees Celsius. Little bit different. This is a hard one with 500. Tetra. What is 1.9 moles per liter? No. Brookdale better. What is 0.992 moles per liter? Good. Let's figure out how we're going to calculate that. When I get my calculator, we're going to explain how it's done. So, we use Henry's law to solve this. Key thing is, I use Henry's law formula. C gas is equal to KH times P. K is the Henry's law constant, and P is the partial pressure. C is concentration. We're trying to calculate the concentration, so we're looking for C. So the Henry's law constant here is 0.03 moles per liter. 0.31 is the Henry's law constant times 3.2 atm, which gets you the 0.0992. Just wrote that wrong on there. So, Tetra, you got control of the Brookdale there? You got that one? Solubility for 5. Brookdale there, you have control of the board. That was a bold move there. Vocabulary for 5. Vocab for 5. Okay. Explain what ion-dipole interactions are and what spheres of hydration are. You got a tough one on our hands. Explain what ion-dipole interactions are and what spheres of hydration are. Iodine. Ion-dipole interactions are those that are like the forces that are between the ions and the molecules. Attach and have a permanent dipole. Spheres of hydration, or clusters of water molecules on an aqueous solution ion. Good. Iodine, 500. Let's move. So iodine, you are 1,000. Tetra, you are 1,200. Brookdale, you are at 3,000. Good going. So there's some additional information here, which I should point out to you guys here. There's a sphere of solvation as the solvent is not water. But you can't have aqueous water, of course. You cannot do that. No aqueous water here. Nope. Stop the pointer options. Stop the laser pointer, and we're back to the board. Just did vocab 5. Iodine, you just got that one. So you got control of the board. Dispersion for 4. Dispersion 4. What happens to the solubility when dispersion goes up and the energy of the hydrogen bonding goes down? Tetra. It decreases. Decreases. Right. Good move. Tetra, you got 400. You up to 1,600. Good move here. Tetra, you got control of the board. Boiling point for 4. Boiling point for 4. How would you go about ranking boiling points from lowest to highest? Brookdale Bear. First off, you look at the atomic number. The atomic number is higher. You got a higher boiling point. Look at solubility, hydrogen bonding. Look at all that. And you put them in order of increasing intermolecular forces. And the more force you have, the higher the boiling point is. Good. Brookdale Bear, good answer. So basically what happens here is intermolecular forces. We're going to learn about that in a couple minutes. But as they go up, boiling point goes up. And hydrogen bonding is the strongest bonding. And because it's strong, it has a higher boiling point. And the more force you have, obviously, the more boiling point it's going to be. Brookdale Bear, you got control of the board. Boiling points for 2. Boiling points for 2. What happens to the boiling point when you add things to it? Iodine. It goes up. It goes up. Right. It increases. So the more you add to it, the harder it's going to be to boil what you're looking to boil. So water compared to salt water, it's going to take a whole lot longer for that salt water to boil because it's a higher temperature. You raise the temperature of what's in there when you add stuff to it. So, right. Back to the board. Boiling points for 1. Boiling points, 100. Do ionic or covalent compounds have a higher boiling point? Ketchup. Ionic, because they're stronger. Good. Ionic compounds are stronger. They got higher boiling points. Remember, ionic compounds are between a metal and non-metal. Covalent compounds are between ionic compounds are between metal and non-metal. I think, yeah, ionic compounds are between 2 non-metals, and covalent compounds are between a metal and non-metal. I guess that's how it goes. Sure, you got control of the board. Vocab for 3. Vocab for 3, okay. Which word tells how easily the electron cloud can be distorted, being temporary dipoles? Iodine. What is polarizability? Right. Polarizability. Good. Electron cloud gets distorted and temporary dipoles are created as a result of that. Iodine, you got control of the board. Vocab for 4. Vocab for taking some risks. Which word means resistance to flow and what are some factors of it? Ketchup. What is viscosity? And factors are more mass, shape, and texture. Good. Good. Ketchup, that's 400 on your part. Before we continue, you have control of the board when we are done. But let's start calculating. Iodine, you're at 1,500. Tetra, you are at 1,600. You're at 2,100. And Brookdale Bear, you were in the lead with 2,900. It is anybody's game here. Anybody's game. Tetra, you got control of the board. Which category would you like to see? Vocab for 2. The wrong numbers here. 1 second. Vocab for 2, okay. Vocab for 2. Compare and contrast intermolecular and intramolecular. Compare and contrast intermolecular and intramolecular. Brookdale Rep. They're no different. No. They are different. So you lose 200 points from that. Iodine. What do you got for this? Like the forces that attract and the forces that repel combined between electron pairs. Those are intramolecular forces. And intermolecular when they're acting between ions and molecules. Good, yes. Iodine, you got 2 200 more. Tetra, you are 2100. This is anybody's game right now. Iodine, you got control of the board. What would you like? Other for 3. Other for 300. What are the 3 properties of water? Define them. What are the 3 properties of water? Define them. Tetra. What is surface tension, viscosity, and related to molecular forces. Surface tension is how much energy is required to separate the molecules in the liquid surface. Viscosity is how measure the resistance for liquids to flow. And yeah, that's about it. Good, Tetra. That's 300. And on to yours, 300. Now you have control of the board. Dispersion for 4. What happens to the solubility when dispersion goes up and the energy of the hydrogen bonding goes down? Brookdale rep. What if it goes up? No. Tetra. What if it goes down? Yes, it goes down. Right. 400. This is still anybody's game here. So all we have left is solubility, 1 to 4, and we have other 1 to 2. So Tetra, you have control of the board. What would you like? Solubility for 1. Solubility for 1. What is the difference between hydrophobic and hydrophilic molecules? Brookdale rep. What's hydrophobic, likes to repel water, and hydrophilic likes water and it wants it to be soluble. Good. Brookdale there, a little makeup for that one. Now you have control of the board. Solubility for 2. Solubility for 2, okay? What does the solubility of a gas depend on? What is the solubility of a gas depending on? Solubility for gas. Iodine. What is the partial pressure of the gas above the liquid surface? Good. Partial pressure of the gas. Good answer. 200. You're all going up. Nobody's in the negatives. This is going well. Move forward here. Solubility 2 is set. Iodine, you have control of the board. Solubility 3. Solubility for 3. Okay. What is Henry's law? And what is the equation? What does each variable in the equation represent? Brookdale rep. Henry's law equation is C of gas is equal to K H times P of a gas. C is the concentration, K is Henry's law constant, and P is the partial pressure of the gas. Good. Brookdale there, you got 300 more. Cancels out the -400. Yeah, back to the board. Brookdale there, you now have control. Solubility for 4. Solubility for 4. What does solubility depend on? Tetra. What is the strength of it? Yeah, the strength. Good. Good answer. So now all we got left is other for 1 and 200. But before we get into that, I'm going to explain this. Solute solvent, like salt and water. Like the salt dissolves in the water. The solvent is water. The solute is salt. Solvents, they're not going to dissolve. Solute, everything's going to dissolve. Basically, that's how this operates. Tetra, you have control of the water now. Other for 2. Other for 2. Which word means a liquid rising in a narrow tube because of adhesive forces between the liquid and the tube and cohesive forces within the liquid? Brookdale Bear. What is capillary action? Capillary action. Good. Capillary action. 200 you got for that one. And the last category is other for 1. What is the difference between adhesive forces and cohesive forces? Iodide. What is adhesive forces? It's interactions between different particles. And cohesive is interaction between like particles. That is the right answer, I would say there. Different particles interact. For adhesive. And the same one is cohesive. Now, we got through the board, we made it through. So now we're going to find out your totals. Let's see here. Iodide, I'm going to add up your totals now. Find out. 2 and 5 is -3, plus 4 is 7, plus another 4 is 11. You're at 2,100, 23, 26, 28, 3,000. Iodide, you have a total of 3,100. 3,100. Tetra, you have a total of 9, 12, 16, 2,000, 2,100, 24, 26. Tetra, you are 3,000. So close here on Final Jeopardy. Brookdale Bear, 3,000. You have 2, 33, 35. Brookdale Bear, you are $3,700. $3,700. Iodide, 3,100. Tetra, 3,000. Brookdale Bear, 3,700. Now, I want you guys to think about how much are you going to wager in Final Jeopardy. So here we go. Final Jeopardy, there is no category. All right, so final Jeopardy question for the day is, considering the compounds, carbon tetrachloride, ammonia, hydrogen fluoride, and oxygen, which should be very soluble in water, and which should have limited solubility in water? All right, let's see what you put. Iodide, let's see what you have here. You have NH3 and CCl4 is soluble, and you have hydrogen fluoride and oxygen with limited solubility. No, that is incorrect. How much did you wager? $1. So, iodide, you did not lose much, and your final total here is $3,099. Good move. Tetra, let's see what you wrote. You have ammonia as ammonia and hydrogen fluoride is soluble, and then the other two is limited solubility. You are right. Let's see, what did you wager today? 2,900. Tetra, you go. You are at 5,900 is your final total today. 5,900. Your final total. Tetra, you are at 5,900. The Brookdale Bear. Let's see what you have. You had the same answer. You were correct as well. You only wagered 500 though, which pulls you to 4,200. Our winner for today is Tetra with 5,900. Tetra, you are today's winner. Now I would like to see you explain how to solve this problem. All right? So Tetra, take it away. All right, so here's what you do first. You find out what compounds are polar and what's non-polar, and you determine that based on the Lewis dot structure and the molecular geometry. And you figure out that ammonia and hydrogen fluoride are polar. And what's non-polar is the other two, which is carbon tetrachloride and oxygen, are non-polar. And polar molecules are soluble in water, and the non-polars have limited solubility. So, the ones that we said were polar, ammonia and hydrogen fluoride, are soluble. Oxygen has limited solubility. Okay, and before we finish for today, chemistry jokes for the day. Brookdale Bear, you come right up here and you tell us our chemistry jokes. What do you call an acid with an attitude? What? Amino acids. I slapped my knee on that one. Then look at that picture right there. Chlorine, helium. Oh my gosh, that looks good. And just to congratulate all the winners before we end today, we got Tetra in first place with 5,900. Congratulations. We got the Brookdale Bear in second place with 4,200. Io died, you were in last place. Don't worry, you had 7 electrons, which doesn't make you feel better anyway. Did you want that last one? And you have 3,099. So good job today, everyone. And I guess it's time now for Wheel of Fortune. And this is your sources. I mainly use the Chapter 10 PowerPoint to do this off of. And I got this worksheet from there and the pictures we researched. I found the pictures based on that. And that is today's Jeopardy. I hope you enjoyed our show.